So one of the reasons why we talk about rational functions is because they're really our first example of asymptotes. To talk about asymptotes, I'm going to have to introduce some limit notation. So I'm going to write the limit as x goes to infinity of some rational function r of x. And if that exists and equals L, what does that mean? That means that eventually r of x stays as close to the line y equals L as you like. So the idea is that if you tell me how close you want to be to the line y equals L, we can wait long enough going towards infinity so that our function is always that close. It has to stay that close from that point to infinity. So by now everyone knows that I like Desmos. So here's a graph in Desmos of sine of pi times x over x. And I'm just showing you the positive side. And it has an asymptote L equals 0. Now, the dotted lines represent the interval around that line, L equals 0, that we need to be constrained by. Right now, that interval is from negative 0.5 to 0.5. But as I make A smaller, right, you can see that eventually, close to 0, I'm outside of that interval, right? But if I move my graph and look further down as x tends towards infinity, eventually I get inside that interval again, and I stay inside that interval. Staying inside is important. So let's make it even smaller. Now this is teeny tiny, so I'm going to have to zoom in. But you can see that if I go far enough down and zoom in enough so I can actually see what's going on, I'm going to stay inside that interval from then on. And it doesn't matter how small I make A, as long as it is greater than 0, I can get far enough towards infinity so that my graph stays inside my interval. So now what does that have to do with horizontal asymptotes? Well, if r of x is a rational function, and the limit as x goes to infinity of r of x equals L, then y equals L, the line, is a horizontal asymptote of r of x. Now the reason I specified that r of x is a rational function is because there's a more general notion of horizontal asymptote where we need to be a little bit more careful. But because of the properties of rational functions, this is sufficient for our case. So this is what we're going to take as our definition of a horizontal asymptote for rational functions for now. So now here's the graph of a rational function, 3x plus 2 over x plus 2, and we're just looking for the horizontal asymptote right now. So to do that, we don't care about what's going on near 0, where our window is right now, so let's move over to where x gets big, right? So we're at 42, which here is big enough for us. It's always the answer in any case. So when we zoom in, we can see that we've gotten very, very close to the line y equals 3 already. And if we go further and further and further and further and further and further and further, maybe I'm making you sick by watching all this, you can see we're getting even closer. So we're tending to 3 as x tends toward infinity. So our asymptote is in fact y equals 3. On your homework, they're going to indicate these asymptotes with a dotted line similar to this one. So when they're asking you about asymptotes, you just have to figure out where they are. They're drawing the asymptotes for you.